Okay, so question number 8 related to nuclear and particle physics question. Question is from January 2022, question number 17. So what does the question say? The very first part is experiments with muons are taking place at Fermilab in the USA to improve our understanding of the Standard Model. The muons belong to the family of particles as the electrons. Okay, we know this already. We also know about this. So they're asking us that state how the muon is classified in the Standard Model. Okay, so before we begin this question, you should know that muons and electrons are both part of the lepton family. The lepton family. So in the Standard Model, we know that the muons are classified as leptons. So this is a 2-mark question. So very first thing that you're going to write is that it is classified as leptons. And why is it classified as leptons? Because we know that muons specifically belong to the second generation of leptons, where the first generation contains the electrons. So for example, the leptons family consists of muons and electrons. The electrons belong to the first generation and the muons belong to the second generation of leptons. So this is for 2 marks. The first pointer that you're going to write is it is classified as lepton. The second pointer would be that it belongs to the second generation of leptons. This is it. This will be your answer for 8A. Now, question number 8B. Okay, so in this question, they have provided us an equation in which over here we got a negatively charged pion. This is a negatively charged pion. And then we have negatively charged muon over here. This is also negatively charged. And this over here is our anti-muon or anti-muon neutrino. Okay. So remember these symbols, what are they representing? So we should know that these negatively charged pions is this negatively charged pion is basically a meson composed of quark antiquark pair, and in this decay the energy from the pion is transferred into producing the muon and the anti-muon. Okay, then over here, this anti-muon neutrino is the antimatter counterpart of the muon neutrino, and it is it is electrically neutral and it is almost massless. We should know about this. So, in the question they are saying name the 2 other particles involved. So, we know what these 2 other particles are. So, the first particle that is being created is a muon, which is negatively charged, and its symbol is represented by this sign. And the other particle that is made is anti-muon neutrino. I hope this is clear to you. Now in part C, what are they saying? A website states the rest mass of a muon is 106 mega electron volts per c square, which is a little over 200 times that of an electron. All right, so and the next part they are asking us that deduce whether this statement is correct or not. All right, so what should be our approach to solving this question? The statement that they have provided us is what, that the rest mass of a muon is what, 106, and it is little over 200 times. So the mass, the very first thing that we should know is the mass of an electron. So what is the mass of an electron? I'll do the working over here. Okay, so let's write down the data first. What do we have? Okay, so the rest mass, they told us the rest mass the rest mass of muon is 106 mega electron volts per square, and it is 200 times over that of electron. So what is the mass of electron? That should be the first question. Then only we'll be able to multiply 200 with the mass of the electron and we'll get the rest mass of muon. So like we'll be able to compare it basically. So the mass of electron, or the rest mass of electron, is 0.511 mega electron volt per c square. They're telling us it is over 200 times. So we have the mass of our electron over here. Now what we will be doing is we just need to calculate and see whether it is right or not, to reduce whether the statement is correct. They are saying the rest mass of a muon is basically little over 200 times than that of an electron. So let's find the mass of muon now. How will we know that whether it is 200 times over or not? We know that the value that they have provided to us about the mass of the muon is what? 10. What I will do is I'll simply divide this value with the amount that we know about the electron, and that would be 0.511. Okay, remember this calculation, this ratio that I'm finding out is in this same unit. So what I did was I converted the mass of electron into mega electron volt per c square. Okay, so this is the ratio that I'm getting. I'll get the answer directly. So using the calculator, this is giving me 207.44. So this clearly shows that the rest mass of the muon is over, like it's 207 times than that of the electron. So the statement is correct. This is one way for solving the question. I did this directly by just converting the mass of an electron into mega electron volts per c square. Another way to solve this would be if I convert these masses into kg and then I find the ratio and I'll get the answer. So I'll show you another working as well about how to get the answer in kg. So let's first quickly remove this part. Okay. Now, so another way would be by using the equation that we know is E is equals to mc square. We know this equation. Okay, so in this equation we get the mass, we make the mass subject, it becomes m is equals to E upon c square. Alright, after this now we know that E is the rest energy that is converted into joules, where c square is the speed of light that is squared, and we also know another value that we should know is what is the value of 1 mega electron volt? How much is it? It is equal to 1.6 into 10 to the power minus 13 joules. So you should know about this as well. Okay. We know that 1 mega electron volt is equal to 1.6 into 10 to the power minus 13 joules. Using all of this data, let's convert the mass of muon into kg. The mass that is provided to us is in mega electron volts per c square. So how will I convert it? I'm going to write all these values over here. The mass will be in kilograms. I'll change the color for you over here. Okay. So how much is the mass that they have provided? It is 106. I'm converting this value into joules. So 106 multiplied by mega means 10 to the power 6. Now multiplying it by 1.6 into 10 to the power minus 13 will give me the answer in joules. This becomes my energy, and I divide this energy that is converted into joules into by the speed of light. And what is the speed of light? The speed of light is 3 into 10 to the power 8. And we have a square over here, so I put a square over here as well. So the mass of muon will be 1.88 into 10 to the power minus 28 kg. This is the mass of the muon. Now we need the mass of electron. So we know already that the mass of electron in kg is equal to, the mass of electron is actually equal to 9.11 into 10 to the power minus 31 kg. It will be provided to you in the formula sheet. This is mass of electron, this is the mass of muon, and you divide it. So we get the ratio over here. The ratio would be the mass of muon divided by the mass of electron, and hence this will give us 1.88 into 10 to the power minus 28 divided by 9.11 into 10 to the power minus 31. So the answer is around, again, 207 times. So it is clear that the statement is correct and the mass of muon is over 200 times in that of the electron. That's it. Okay, so question number 8, part D. Muons are stored in a storage ring at the Fermilab. The website describes the ring as having a circumference of 44.7 meter and using a magnetic field of flux density 1.4 Tesla. The website claims that this enables the storage ring to confine muons with a momentum of 3.10 giga-electron volts per the speed of light, the per c. So explain why the unit giga-electron volts per c is a valid unit for momentum. Okay, this is for 2 marks. So let's talk about the formula for the momentum first. We know that the momentum is equal to the mass multiplied by the velocity. It is equal to mv. And according to the Einstein's equation, which we have is E equals to mc square. We have these two equations and we'll have to see that whether we are getting this unit or not. Okay, let's see. Let's first try to combine these together. Let's try to make this Einstein's equation part of the momentum. So I'll have to make something common. Let's take the mass as common over here. So if I make mass the subject, the mass will be equal to E upon c square, and I substitute it in the formula of my momentum. So it will give me P equals to, in place of M, I'll write E upon c square and multiplied by V. So we know that the velocity for this momentum will also be equal to c. In place of v, I'm going to write c. So c and this c cancelled out, and what we get is p is equals to e upon c. Where now let's convert this into like the units. Basically, the energy is provided in, where is it written? This value over here. So we know that the unit giga-electron volt is a common unit of energy in particle physics. So this energy, we know that this is in already giga-electron volts. And what is over here? Below it in the denominator, that is C. So the momentum has units, what? The energy is in giga-electron volts upon C. And what was the website claiming over here? The website claims that this enables the storage ring to confine muons with the momentum of 3.10 giga-electron volt per c. So this is how you will explain why this is a valid unit for momentum. Okay, and I'll summarize it up for you. You should know that the unit of energy is in giga-electron volt. So the unit of energy in giga-electron volts. We know that the unit of mass, according to this, would be like, if mass is equals to mv, we put the energy upon c square in place of mass by substituting it. What we get over here is E upon c, and we know that the unit of energy is giga-electron volt. So giga electron volt upon c will be the answer, and it is correct unit for momentum. This is the unit for momentum. Okay, I hope this is clear. Now let's move on to our next part that says reduce whether the website's claim is correct. They are saying that the muons charge is negative 1.6 into 10 to the power minus 19 coulomb, whereas we have this value over here, we got a ratio over here that is provided where they're telling us that 3.10 giga electron volt per C is equals to 1.65 into 10 to the power minus 18 Newton second. Okay, let's see how do we solve this question now. Okay, let's quickly first compile the data what is provided to us. The muons are stored in a storage ring, and the website describes the ring as having a circumference of 44.7 meters. So let's first write down the circumference of the storage ring. So C is equal to 44.7 meters. We got the first value over here. Then what do we have? It's using a magnetic field of flux density 1.45 Tesla. So the magnetic field strength is B is equals to 1.45 Tesla. And what else? Next, what we should know is the charge of muon. What is the charge of muon? It is 1.6 into 10 to the power minus 19 coulomb, and the momentum of muon is, here is the momentum provided, this is the momentum, okay, and this is the charge, I've already written it, and the momentum of the muon is, so this is P is equal to 1.65 into 10 to the power minus 18 Newton second, that is mv, the momentum. So how do we solve this question now? To deduce whether the website's claim is right or not, what we will be doing is we will be finding the value of the circumference. First, we will be finding the circumference using the general formula of our circumference. We know that the particles would be moving like in a circular path, right? So the circumference is going to be C equals to 2 pi r, the basic general formula. We will be using this formula, and making r the subject would give me C upon 2 pi. Okay, I'm going to be using this to find the value of r, and next I will be using the formula that we already know for the particle in the magnetic field. That would be, we'll be using the formula of the force in a magnetic field along with the motion is circular, so the centripetal force. I hope you remember the lectures when we were studying this topic where I told you that the force of the magnetic field would be equal to the centripetal force, and hence this would give us a formula that would be the magnetic field force is equals to BQV, and the centripetal force is equals to mv square upon r. So when I make r the subject in this formula, this gives me what? This is going to give me mv square upon BQV, where this V and this V is cancelled out. So this whole thing is giving me R is equals to mv upon BQ. And we know that the momentum is equal to mv. So in place of this whole mv, what will I simply write? In place of mv, I'm going to just write P over here. So my final equation would become R is equals to P upon BQ. This would be the second equation that I have reduced. I am going to be using this equation and finding the value of R, and then I'm going to be using this equation and finding the value of R and see whether both the answers are same or not. If the answer is same, then it means that the website's claim is correct. If it is not same, then it means it is wrong. So I'll just remove this part and let's do the working and see whether the values for R. Okay, so R is equals to C upon 2 pi. R will be equal to, we have the circumference, 44.7 over 2 pi. When I solve this, this is giving me 1 minute. I'll solve it real quick. Okay. Okay. So yeah. So this is giving me 7.11 meter. This is the radius when I'm getting when I'm using the circumference formula. Next, I'll be now using the second equation that I have, that is R is equal to P upon BQ. So R is equals to, what is P? P is 1.65 into 10 to the power minus 18 upon what is B? B is 1.45 Tesla, and Q is 1.6 into 10 to the power minus 19. Putting this in the calculator, what does this give me? Give me a second. This calculator and let you know. Okay, so yes, this is also giving me 7.11 meters. So as you can see that the radius is same for both of them. By first getting the radius through circumference formula, and in the second part getting the radius through the momentum formula, it is confirmed that the website claim about the muon's momentum is correct. Okay, so just write that the website's claim is correct after this. Now, the last question of this question number 8 is, uh, in this question they are asking that why muons in the ring are observed to have a much greater mean lifetime. So in easy words, what you need to understand is the concept of time dilation. So what does time dilation tell us? The time dilation tells us that the faster you move close to the speed of light, the slower will the time then act on you. Okay, so basically when the muons are moving very fast, let's say almost at the speed of light, then they experience this time dilation. So this means that time for them seems to slow down. Now normally muons decay very quickly, but because they are moving so fast, their clock runs slower. So to an observer, it looks like the muons last much longer than usual. So this happens because of the Einstein's theory of relativity, which tells us that the time moves differently from objects that are moving really fast. So to answer this question, the very first point that you need to write down is that the muons are traveling close to the speed of light. Okay, are traveling close to the speed of light. The second pointer would be that according to relativity, time moves slower for objects moving at very high speeds. So because of this also, we see that in the ring we observed the muons are observed to have a much greater mean lifetime because their time is running slower than us as they are moving at this at like almost at the speed of light. That's it.